Alright, this example is to show how to correctly handle overflows in comparisons. So what you see here are two circuits. The first one is labeled wrong circuit and the other one is labeled correct circuit. So what I do is I reset the simulation, and as we discussed in the previous tutorial that uh, if you don't handle overflows correctly and two numbers, the two inputs add up in such a way that they wrap around, then you would get a wrong result. So I can demo that here with the wrong circuit such that A is an 8-bit number and A is set to minus 128, and right now it shows that A is smaller than B, which is true. But if you set B to 64, then you'd see that the comparison result shows that A is greater than B, which is not really true. And I've already explained the reason for that in the tutorial. Um, the logic that gives out the result of the comparison does not take into account the overflow. It just looks at the result from inputs the result from that line and makes a decision based on that, based on the comparison with 0. And of course, because of the wraparound, when you subtract max 64 from minus 128, you get 64. So comparing 64 with 0 gives you the wrong result. Whereas the correct circuit should be able to give you the right result. So now you see that when you compare minus 128 with 64, you get the right result, that is A is smaller than B, despite the fact that the result of the adder or the subtraction is still the same as was in the previous case. But the difference here is that both the inputs are being taken into account in the logic that determines the result of the comparison. It also takes into account the result of the subtraction and then makes a comparison to see if both the numbers that are being input to the adder have the same sign, and if that is the case, is the sign opposite to that of the result. If so, the decision is inverted, and that is what this circuitry is doing. So you have to take care of handling this when you build the ALU, the 32-bit ALU. You need to make sure that you get correct signed arithmetic.